Welcome back. In this chapter we will be covering the concepts of Object-Oriented Programming System, most commonly referred to as OOPS. Object-oriented programming is one of the most crucial and groundbreaking patterns that changed the world of software programming. This is what we will be learning in this chapter. Introduction to OOPS. Object-Oriented Programming System, or OOPS, is a software coding pattern where objects are created to execute specific tasks. These objects have a well-defined form or data structure and are designated with definite roles or the functional features. Before creating a functional object, we first have to create a prototype or model of this object. This model is called the class. A class comprises of member data fields and related functions that operate upon those data to achieve a specific task. The data within a class are supposed to be modified only by functions within that class. Data and functions that are held together to make a specific class are said to be encapsulated in the class. Encapsulation provides exclusiveness and protection to both the data and functions within a class by preventing direct access and modification of data from outside the class. Based on the prototype model or the class, a block of temporary memory storage space is reserved or allocated to store member data and member functions of the class. The memory storage space that is allocated for a class is the object of that class. The process of creating an object from a class is known as instantiation. Difference between C++ structure and the class. The structure comprises of data fields, whereas the class has both data fields and functions that operate upon those data fields. Real-world example of an object. An object in OOPS is similar to any real-world object we see around us. All objects have a characteristic state, giving it form and shape, and the functional behavior, that is, setting up of its roles. For example, if we consider our mobile phone as an object, then it would have its own characteristics and functionality, as depicted here. The characteristics of the mobile phone object would be its display screen, outer cover, SIM card, memory unit, battery, motherboard, etc., and its functionality would be the abilities of making calls, sending SMS, video call, WhatsApp, Facebook, YouTube, access, etc. In OOPS, the characteristics may be equated to member data, and the functionality may be equated to member functions. We will now understand class and objects from another very simple analogy. Let's consider the basic model of any aircraft system. It would look like this. It would have the propeller, an engine, landing gears, fuselage, wings with aileron and flaps, the tail with rudder and elevator, just to name a few. Since these essential features are a part of all aircrafts, they form the basic model based on which improved versions of the aircraft can be built. From the context of object-oriented programming concepts, this basic model is the base class, and if we decide to build an aircraft from this base model class, we would be creating the object, or the actual aircraft, like a Cessna 172. Next, let's consider we have modified the base model plan with lots of additional features that facilitates passenger travel for the comfort and luxury of general public. This modified new plan is the child class 1, which was built upon the basic features of its parent or base class. The object that we create from such a child class can be the Boeing 737. Similarly, we modify the base class with additional precision-specific features and create another model plan, the child class 2. It's modeled for building the fighter jet aircrafts. So we create an object using this class, and here we go. It's the F-22 Raptor. Let's now take a quick review. What is object-oriented programming? Object-oriented programming is a very effective and productive software coding pattern that works on the basic concept of class and objects. Class is a user-defined data type. It is a package of encapsulated data and functions or operations that process the data. Class is a logical entity. Object is an instance of a class which binds the modules of data and their specific operations in real-time implementation. Object is the physical entity of a class. Object-oriented programming facilitates reusability of the program code, standardization of software development, and faster scaling of available program scripts. Object-oriented programming provides modularity to the program structure for easier troubleshooting and accurate debugging. Flexibility and efficiency in program coding is provided by basic principles of OOPS, like class, objects, methods, encapsulation, inheritance, polymorphism, and data abstraction. Features of object-oriented model. Object-oriented programming is all about developing an application with well-protected data and limited access to functionalities. Hence, the object-oriented model strongly deals with features for data hiding and function accessibility. For example, data and functions that are grouped together in a class might have private data and public functions. This ensures that private, internal data is safe from external intrusions and that they can be accessed from outside of the class only through public, member functions belonging to the same class. Object-oriented programming model incorporates the following 4 primary features: encapsulation, abstraction, inheritance, and polymorphism. Number 1. Encapsulation. Encapsulation is the process of wrapping together, or grouping of data and functions into a single entity, the class. Encapsulation provides protection to the data and functions within a class by preventing direct modification of the data from outside the class. The implementation details are kept private to an object. Restricting access to the functions and data reduces coupling or data duplication, which in turn increases the data reliability in large programs. Classes also encourage coherence or guarantee, which means that a given class does one specific task. By increasing coherence, a program becomes easier to understand, less complex, more simply organized, and there is a further reduction in coupling. Number 2. Abstraction. Abstraction is the process of hiding data access from outside of a class and showing only relevant data. For example, when you log into your Gmail account using your user ID and password, you do not get access to internal program that verifies you, or to the database that stores your details. Such functions are said to be abstracted away from you. Number 3. Inheritance. Inheritance is the process of creating a new class from an already existing class. The newly created child class not only inherits all the characteristics or properties, the data, and functionalities of the parent class, but also adds up its own data and functions. The new class is called derived class, child class, or subclass. The original class is called base class, parent class, or superclass. Number 4. Polymorphism. Polymorphism is the ability of a function to perform multiple tasks under different circumstances. There are 2 types of polymorphism: static polymorphism and dynamic polymorphism. Static polymorphism is exhibited by overloaded functions. Please refer to the chapter on functions. Static polymorphism is the technique of overriding a function by providing additional definitions with different number of parameters or with different data types as parameters. The compiler matches the parameter list to appropriate function that is called in the program. Remember how we used function polymorphism, where we defined multiple functions with same name but with different parameters? Here are 2 examples of the add function. In the first one we would pass 2 integer parameters, for example, to add the number of students and teachers in a school. And in the second one, we would be passing 2 float parameters to add the cost of 2 separate items. Dynamic polymorphism is exhibited when using late binding. In dynamic polymorphism, the parent class has a declared or defined virtual function, which can be redefined in a child class. At runtime, using appropriate objects, we can either use the function within parent class or child class. The decision to use required function, that is, parent or child, at runtime, is termed late binding. This feature increases the flexibility of a program by allowing the exact function to be invoked.